what we're going to cover today is how to solve equations that contain radicals. But before doing that, let's just take a look at the do now, because it's similar in concept to what we're talking about. If we have x squared minus 4 equals 0, um, hopefully you now realize that it's much simpler to solve this by using radicals, because I can just isolate the constant, take the square root of each, and I'll get x is plus or minus not 4, but 2. Right? The second one, you would notice that that's something you cannot solve by using dots, which you could do with the first one. So you get x is plus or minus radical 24, which is approximately 4.9. And then hopefully you'll see in the next one that when you isolate and you get x squared equals negative 4, that there's no real number solution. Okay? Now, what we're going to do today is solve when the radical has a variable contained in it. So, a radical equation is an equation that has a variable in the radicand. And you'll see when we do these steps, it's pretty straightforward. Okay, so step one is to isolate the radical on, oops, not a double O, all the snow has gotten my brain frozen, on one side of the equation, i.e., it's an i.e., an abbreviation for that is a radical and non-radical cannot be on the same side. And as with all of these things, once we go through examples, you'll see how straightforward it is. Okay, step 2, square each side of the equation. So instead of taking the square root, we're going to be squaring. And then finally, solve the equation and check for extraneous solutions. Okay, so let's go through some examples. I have radical x plus 7 equals 16. So I'm going to get rid of the 7. So I have radical x equals 9. I square both sides. And I get x is 81. Okay. Now this one, I have radicals on both sides, so I can just go right to squaring them. So that I get 5t minus 11 equals t plus 5. Now I'm just solving a linear equation. Subtract t. 4t minus 11 equals 5. Add 11. And 4t is equal to 16. So t is equal to 4. Okay? And the next one, again, the radical is already isolated, so I square both sides. I get n squared equals n plus 12. Hopefully you're saying to yourself, I have a quadratic equation, so that means I have to set it equal to 0. I have to factor using, in this case, I am. And I get as my answers n equals 4 and n equals negative 3. Now, here is an example where you need to check for that extraneous solution. When n goes in, when 4 goes in for n, we simply see that works. That's good. But when negative 3 goes in, negative 3 is not the square root of 9. So this is an extraneous solution. So when writing it in set notation, you would write as 4 being your only answer. Okay. Next one, I'm going to square both sides, and I get y squared equals y plus 6, because negative y squared means negative y times negative y. I get y squared minus y minus 6 is equal to 0. I get y minus 3 and y plus 2 equals 0. I get y is 3 and y is negative 2. Now, what you'll see is this answer is extraneous, because when you put 3 in, it's negative 3 because of that negative sign out there. Okay? And the next one, I square both sides. I get, well, I'm sorry, first I got to get rid of that 8. So I get the square root of 3y equals negative 6. I square both sides. I get 3y equals 36, or y is 12. Now I'm going to check my answer. So the square root of 3 times 12 plus 8, the square root of 8, equals 2. Square root of 36 plus 8 equals 2. 6 plus 8 does not equal 2, so there's no solution. Now, the way you could see this is that when you subtracted, you've got a radical equaling a negative number, which is in the real number system something that is not possible. All right, and then the last one, the time it takes for a pendulum to swing, is represented by this formula. I want to know what it is in 3 seconds, so I put 3 in for t. 2 radical L over 3.3. So I want to isolate this radical, so I'm going to divide by 2. So I get 1.5 is equal to the square root of L over 3.3. Now I'm going to square both sides, and I'm going to get 2.25 is equal to L over 3.3, and I cross multiply to get 7.425 is equal to the L. Okay? So again, today we did solving radical equations. The key step here is that you want to isolate that radical, okay, on one side. If there's 2 radicals, they can both be then on opposite sides. Square them and solve.